Today I am going to explain the second experiment of Physics 1, uniformly accelerated motion. So this experiment is from your chapter number 2. We already studied that 5 equations, am I right? So we are going to use that equation in this experiment. Let's see what is our objective. What is our objective? We are going to study the relation between distance and the time. My dear, this experiment is purely one-dimensional point of view. So in one-dimensional point of view, your distance is equal to displacement. Clear? So either you can say this one, relation between distance and time, or displacement and time. Both are correct because we are dealing with one-dimensional point of view. So we are going to study the relationship between the displacement and time, and then we are going to find the value of g. Clear? So for calculating this g value, we are going to use this equation, and this equation will be given in your paper. So what is that equation? x2 minus x1, which is equal to g sine theta t square. So by using this equation, we are going to calculate the value of g. So how you can arrange? G, which is equal to 2 multiplied by x2 minus x1 divided by sine theta multiplied by t square. So if you want to calculate the value of g, distance or displacement, time parameter, and the theta, these three are very, very important. Clear? So we are going to measure each and everything in the table. So if you just see the table, we have two data table, data table 1 and data table 2. Data table 1 is for calculating the value of theta. Table 2 is for calculating the value of displacement and time. So if you want to calculate, if you want to draw the graph, it's from only the second table, not from the first table. So for drawing the graph, we are going to use the second table, but for the calculation of the g value, we need the theta also. So we have to fill both table perfectly. Clear, my dear? So if you want to calculate the theta, what are the information you need? You need the distance, height 1, height 2, and then you have to calculate h2 minus h1 over L, and calculation of the theta is from this equation. Is from this equation. Clear? So now I am going to show you the apparatus, and I will tell you what is this L, what is this h1, what is this h2. So once you know the L, h1 and h2, you can easily find the value of theta. Generally, here if you just see the table, we gave 3 columns, column 1, column 2, column 3. Sorry, row 1, row 2, row 3. Am I right or not? So 3 times you have to measure the theta, and after that you have to calculate the average. But generally, we give the value in your exam. Clear? But today what I am going to do, I am not going to measure 3 times, I am going to measure only 1 time, and with the help of that value, we can easily find the theta, because we have only 1 theta. If you measure properly, that will more than enough. Clear? So now what I am going to do, I am going to show you the apparatus, the components. If you just to see this apparatus here, we are going to use the air blower. Here you have the switch, which is on off button is there, and then here there is a turning knob. You have to make this turning knob to the maximum. Clear? And if you just see the back side, we attach the wire, the tube, which should be connected with a lengthier air track. You can see this air track, it is very lengthy. So if you just see this air track closely, you can see there are a lot of holes. There are lot of holes. So through this hole, once you turn on this air blower, air will be coming through this tube. When the air entered this air track, air will be coming out of this air track. Why? Because we have to avoid the friction for some experiments, some procedures. And apart from that, we are going to use 2 gates, 2 photo gates. Photo gate 1 here, photo gate 1, and this one is photo gate 2. So you have to fix the photo gate 1 and photo gate 2 to some respective position, and then you have to measure the time again by using the timer box. I will explain you clearly once I take one reading for your reference. And then the most important thing is the glider. So what you are going to do, you are going to take this glider and you are going to put this glider to the extreme end. If you just see the air track, there are some measuring scale is there. So when you fix this this glider here, you have to fix the position of the photo gate to the edge of the glider. To the edge of the glider. So that means the initial speed of the glider. What will happen when you turn on the blower, air blower, air will be coming through this tube. Once the air entering the air track, air will be coming out of this hole, and by the time what will happen, friction between this layer and this layer will be low. Am I right? So when you just put this glider here, when the air will be coming out of this air track, there will be no friction. So by that, this glider will be sliding very smoothly. Clear? So what you have to do, first you have to fix the position of the L. First you have to fix the position of the first photo gate, and also you have to fix the position of the second photo gate. Now if you just see the table, we have to fix the length. So how you can fill the value here? So for filling this table, you no need to take any calculation by using this apparatus. The simple thing, for filling this table, you need the meter scale. Clear? You need the meter scale. So now I'm going to explain what is your L. So if you just see the photo, if you see the air track, there are different readings. Am I right? Starting from 0, 1, 2, 3, 4, 10, 20, 30, 40, 50, like that. Different readings are there. Am I right or not? So what you have to do, if you want to write the value of L, choose any two readings from the scale. Choose any two readings from the scale. For example, what I am going to do, I am going to choose 20 and 40. Or if you want to choose 30 and 80 or 30 and 90, it's up to you. Choose any two readings from the scale. Clear, my dear? So if you choose any two readings, that will be more than enough. So for today's explanation, which reading I am going to use? I am going to use the reading 30 and I am going to use the reading 90. Clear? So 90 minus 30. What should be the answer, my dear? If you just see here, 90 minus 30, which is equal to 60. My 60 is the length. Clear? So I choose 2 points from the scale, 90 and 30. If you subtract this 90 with 30, you will get 60. So here I use 90 and 30. 90 minus 30 gives me 60, which is the value for L. Clear? Now how to measure H1 and H2? My dear, generally the H2 value will be greater, H1 value will be smaller. Because why? You have to use this formula. If you take this value as greater, then your value will be negative here. So you have to avoid that. So what you have to do, this will be the larger value, this will be the smaller value. Clear? So how to measure this? We choose 90 and 30. Am I right? So what you have to do, you have to take your meter scale. So now you can see the air track. We have 30. Am I right? So from 30, I am going to measure the height from the table to the edge. From the table to the edge. So you can see here, from the table to the edge, I got the value as maybe 27.1. So I got 27.1, which is nothing but H2, 27.1. And then H1, how you have to measure? The smallest value from 90, because our value is 90 and 30. So if I measure the height of this 90, let's see what should be the value. It is exactly 20. Am I right? So 20. I have to write 20 here. So once you know the value of L, H1 and H2, you can easily find the answer. Am I right? So what I am going to do, I am going to use my calculator. Let's we just calculate. H2. What is our H2? 27.1. So I am going to type 27.1. So better wait. 27.1 minus H2. H2 is this one, H1. What is that value of H1? 20. And divided by L. What is our L? 60 is our L. So I have to, when you just do these things, what should be your answer? 0.1183. So I am going to write this value here, 0.1183. Clear? Now once you find this, calculation of the theta will be very easy by using this relation. What is the relation? Sine inverse of this value. So if you want to calculate the value of theta, my dear, the most important thing, you have to measure the value of theta in the degree mode from the calculator. If you are using the radian, then your reading for this theta will be wrong. Clear? So already my calculator is in degree mode. You can see here there is small letter d. That means it measured the value of degree. Okay. So what I am going to do, I am going to fit the program here. What is the formula? Sine inverse. Sine inverse of this value is nothing but 0.1183. So 0.1183 gives you 6.79. So our angle theta is 6.794. So you have to actually, as per the procedure given in the paper, you have to do the same thing for 2 more times. Why? Because to avoid the error in the theta. So generally, if you just see the apparatus, you can see the apparatus here. You can see that corner. We have an inclined position. So that means we have only one angle, and that angle we measured is 6.79. Clear? So here the apparatus is inclined with some angle. So we have only one angle here, and this angle we measured from the first table. Clear? So we got the theta value as 6.79. So we measure the theta. Once we measure the theta, then we have to go back for finding the value of t square x2 minus x1. That means we are going to study the relation between distance as well as the time, or displacement and time. Both are correct. In the second table, we are going to study the relation between displacement and time. So this table we are going to fill now. This table have two information. x2 minus x1 is the displacement, and a t value is the time. T square or t, both are time. Am I right or not? So we are going to study the relation between displacement and the time. Once you know the time, you are going to find the t square by using your calculator. Okay. So because filling this table is very easy. It's nothing. So once you know the value of x1, you can easily find x2 minus x1, because you can see the first table, the first column of the table gives you the information about the x2. So how to write the value of x1? That's a very, very important. Once you write the value of x1, you can easily fill the second column. Clear, my dear? So I will tell you how to write the x1. So if you just see the first part here, how to fix the x1, you have to take your glider and fix it to the extreme end. That means you have to fix to the starting position of the air track. And you can see this is the edge, am I right? This is the edge of the glider. So you have to take your photo gate, and please, my dear, fix this photo gate to the edge. So if you just see the photo gate, there is a center, there is a small hole. So here we have a sensor light. So you have to take your ruler, and please, my dear, you can measure like this, and in such a way you can easily find what should be the value. You can see here what should be the value, 14.3 or 14.2, I think 14.2. So this is the position of x1. So how to find the position of x1? You have to fix your photo gate to the edge of the glider. Why we fix to the edge of the glider? Because the glider initial speed must be equal to 0. For that purpose, we fix the photo gate to the edge of the glider. Clear? So if you measure, we got exactly 14.2. So that is nothing but your x1. So I am going to write x1 value here, 14.1. Clear? Now once you know this value of x1, You can easily find x2 minus x1. Take your calculator. x2 value 60, x1 value is 14.1. So 60 minus 14.1 gives you 45.9. So I am going to write 45.9 here. Clear? Clear? And now we are going to measure the time. How to measure the time? You can just have a look here. This is our first photo gate, position x1. And what is the position of the x2? You can just have a look of the table. What is your position of your x2, second photo gate? It should be 60. So you have the second photo gate here. You have to fix the second photo gate to the 60. So if you want to fix it properly, take your ruler and you can measure here to the center of the photo gate. Clear? So it's exactly 60. Now we have some distance. Distance or displacement, x2 minus x1. So again we have to use the photo gate because two photo gates are connected to the timer. So again you have to give the program. What program? First you have to turn on. And then you have three different color button. Last experiment I already explained. You have to fix the measurement. What measurement? We are going to measuring the time. So if you press one time, time will be up here. Clear? And then you have to jump to the second button, blue color, and here you have to fix two gate mode. Why two gate mode? Because we have photo gate 1 and photo gate 2. So that's what we have to give the program here as two gate. So you have to fix the two gate option here. So if you fix two gate option, you have to press 3 times, I think so. First time if you press, you will get one gate. Second time if you fix fence, if you press third time, you will get 2 gates. And again you have to press this black color button for start and stop. If you press one time, star will appear. Understand? So now what you have to do, the most important thing, you have to move this glider from the position of the first gate to the position of the second gate. When you move the glider, what will happen? When it starts from this point, when it reaches the second position, the time taken by the gliders between these two positions will be given by the timer box. Actually this reading is wrong, so because I am not still turn on the air. So this 4.024 is wrong, my dear. This is just for the explanation purpose. So what I am going to do, first of all, I am going to turn on the air here. First of all, you have to turn on the air. You can see the noise, you can hear the noise. Am I right? And then the most important thing, you have to make the arrow button to the maximum level. Clear? Clear? So I turn on this blower, I fix this arrow to the maximum line. Now the air is entering through this air track through this tube. Now if you just put your hand here, you can feel the air coming out of this hole. Now what you have to do, we already fixed the program. Now I am going to press the start because this is our first reading. My position of the first photo gate is 14.1. My position of the second photo gate is 60. So when I just move this glider, the time taken by the glider from this photo gate to this photo gate will be measured by the timer box. So I am going to leave the glider now. My dear, listen here. I already pressed the star button here. Now you can see here. I am going to release this glider. When I release, what will happen? Air is coming out of this air track. Friction will be 0. So the glider will be sliding very smoothly. So you can see here, I am going to leave here. You can just show this. I am going to leave this. What should be the time? The time taken by the glider from the position x1 to x2 is 1.0642. So I am going to write this reading in the table. So what is my reading? You can see here. Time for moving from x1 to x2 is 1.0642. 1.0642. My dear, you have to write all the numbers. Don't write only 2 digits, okay? Whatever the value you got from the timer box, you have to write everything. Once you finish this value, You can take your calculator. 1.0642 square gives me 1.132. So I told you already, you are going to draw the graph by for using this t square. Only 2 digit after the decimal is enough. So my third digit is 2, so I can write 1.132. My third digit of the value is 2, that means less than 5, so I can write this as 1.12. Clear? Now once you finish the first reading, set your second photo gate to 70. So don't touch the first photo gate. First photo gate position is a stationary. You should not touch this value. Only you have to touch the second photo gate. What is your second photo gate? You can see here, initially we fixed to 60, now you have to fix to 70. So what I am going to do, I am going to move this photo gate to 70 and I have to check the level. Okay. Now again, what you have to do, put your glider to the extreme edge and press the black color button to fix the star here. If I press, star will appear. Now I am going to release this glider. When I release, what will happen? The glider will moving from point 1, that means x1 to x2. The respected time between these two positions will be again recorded by the timer box. You can see here, I am going to release this glider. Release this glider. What's the time? 1.1916. 1.1916. 1.1916. And you can easily find x2 minus x1. What is your x1? 14.1. What is your x2? 70. So that means 70 minus 14.1 gives you 55.9. That is nothing but your value of x2 minus x1. Now once you know the time, because we already recorded, I am going to squaring this value. I am going to write t square. So 1.1916 square, which is equal to 1.419. I need only 2 digit after the decimal. My third digit is greater than 5, so I am going to round this here. That is nothing but 1.42. Clear? So likewise, what you have to do, you have to change the position of your photo gate. What is your position of the photo gate to? 80, 90, 100, 110, 120, 130, 140, 150. Clear? Likewise, only you have to touch this one. Only you have to touch the second photo gate, not the first photo gate. First photo gate is the stationary one. We already measured. Only thing you have to touch the second one, and third reading, you have to move this photo gate to 80. And once you take the reading for 80, 90. Likewise, you have to keep on doing these things. So likewise, once you fill this table, you have to draw the graph. For what you are going to draw the graph? x2 minus x1 versus t square. That means this x2 minus x1 is your y-axis, t square is your x-axis. I already explained how to draw the graph, and please draw the graph. If you just draw the graph, x2 minus x1 will come in your y-axis, and the unit is exactly, it should be in meter. And then t square should be in the x-axis, and the unit for t square is second square. You know how to fix the point. Please, my dear, use the method how to fix the point. Connect the points with a straight line, and please choose any 2 points on the line. I am going to choose the first point and the last point. Find the slope. What is your slope? Delta y over delta x, which is nothing but, in y-axis we took x2 minus x1. In x-axis we took t square. We know the formula for the slope, y2 minus y1 over x2 minus x1. Substitute the value, because this is your x1 value, this is your x2 value, this is your y1 value, this is your y2 value. If you substitute the value here, what will happen? You can easily find the slope value, and the unit for the slope is meter per second square. Clear? Now your slope answer is exactly equal to x2 minus x1 over t square. You can just have a look here. This is our main equation. Here we have x2 minus x1 over t square. Take the value, substitute here. G, which is equal to 2 multiplied by slope value divided by sine of theta. What is our theta here? 6.794. Sine of 6.794, and the slope value, you got some number here. When you substitute, you will get the value of g, and the unit for the g is meter per second square. My dear, this value will be closer to 9.81 meter per second square, which is nothing but the actual value of the g. Clear? Now, after you find the value here, you have to calculate the error percentage again, like your first experiment. So what answer you got? Substitute the value here. This is your actual value of g. Calculate the error percentage. It should be 0 to 20%. Clear? That's it. So in this way, you have to calculate the value of g, and this is the explanation for the second experiment. Thank you.